In the vastness of space, where the infinite tapestry of stars forms a backdrop for human ambition, a new frontier beckons with untold riches. The first trillion-dollar asteroid waits silently in the cosmic void, not for NASA scientists, but for the audacious pioneers of private industry. As we stand at the threshold of this astronomical gold rush, the question lingers: why won't NASA, with its storied legacy and technological prowess, be the first to mine this celestial treasure? Consider this: the value of a single asteroid has the potential to dwarf the GDP of entire nations. Composed of rare metals like platinum, gold, and rhodium, these cosmic bodies are treasure troves that could redefine wealth itself. Yet, it is not the space agency with its government mandates and bureaucratic constraints that will seize this opportunity. Instead, it is the agile, risk-taking private enterprises, unburdened by red tape, that will lead the charge into the asteroid belt. Today, the reality of space mining is no longer confined to the pages of science fiction. It's an imminent economic revolution, driven by advancements in robotics, artificial intelligence, and propulsion technologies. Companies like SpaceX, Blue Origin, and Planetary Resources are not merely dreaming of space. They are systematically engineering the future. With reusable rockets and autonomous spacecraft, they are poised to transform the celestial mining industry from a speculative venture into a pragmatic enterprise. Imagine swarms of drones, guided by AI, navigating the rocky terrain of asteroids, extracting precious metals with precision and efficiency. These technologies are no longer distant aspirations, but rapidly advancing realities. As the cost of launching payloads plummets, the barriers to entering space diminish, opening the heavens to a new breed of entrepreneurs. Yet, the path to mining asteroids is fraught with profound economic implications. The influx of asteroid-derived materials could destabilize traditional markets. What happens when the scarcity of platinum is obliterated by an asteroid landing? Prices for these metals could plunge, disrupting industries that rely on their current value. On the flip side, the reduced cost of rare materials could ignite a technological renaissance, spurring innovation in electronics, energy, and manufacturing. However, these prospects are not without significant risks. The technical challenges of space mining are immense. Landing on an asteroid, securing a mining operation in microgravity, and transporting materials back to Earth are feats yet to be accomplished. Moreover, the legal framework governing space resources remains murky. The Outer Space Treaty, a relic of the Cold War era, provides little clarity on the ownership and exploitation of extraterrestrial assets. As private companies stake their claims, the potential for geopolitical rivalries escalates, raising questions about space sovereignty and resource conflicts. Looking ahead, the stage is set for a transformative era where space mining could become as commonplace as oil drilling is today. Picture a future where orbital refineries process asteroid materials, feeding a space-based economy that supports colonies on the Moon and Mars. The first trillion-dollar asteroid will not only herald a new age of wealth, but also redefine humanity's place in the universe. In this unfolding drama, the role of traditional space agencies may shift from trailblazers to regulators and facilitators, ensuring that the celestial commons are preserved for future generations. The private sector's lead in mining the first trillion-dollar asteroid signals a profound shift in the dynamics of space exploration. It's a testament to the power of innovation when unshackled from conventional constraints. As we venture further into this cosmic economy, one thing is clear: the stars are no longer the domain of dreamers alone. They are the province of those who dare to act, to invest, and to transform speculation into reality. The pursuit of asteroid riches is more than a quest for wealth. It's a pivotal chapter in humanity's journey from earthbound beings to interstellar entrepreneurs. And as we reach for the stars, we must ask ourselves, what will we discover, not just in the heavens, but within our own potential? The first trillion-dollar asteroid awaits, and with it, the dawn of a new era. The journey to mine asteroids is not just a matter of reaching the stars. It's about building an intricate web of technologies and infrastructure that will stretch from Earth to the farthest reaches of our solar system. Central to this vision are the spaceports of the future, orbital hubs that serve as launch points, processing centers, and refueling stations. These cosmic pit stops, will revolutionize how humanity interacts with space, offering a permanent presence beyond Earth's atmosphere and facilitating the constant flow of materials between asteroids and our planet. In this emerging ecosystem, the role of advanced propulsion systems cannot be overstated. Ion thrusters and nuclear propulsion hold the promise of reducing travel times and increasing payload capacities, allowing spacecraft to reach distant asteroids with unprecedented efficiency. The development of these technologies hinges on overcoming significant scientific and engineering challenges, but their potential to reshape the economics of space travel is undeniable. As we look to the skies, the necessity of autonomous systems becomes apparent. The vast distances and harsh environments of space demand machines that can operate independently, making decisions and solving problems without human intervention. This autonomy reduces the need for immediate human presence, cutting costs and minimizing risks. Yet, the reliance on AI introduces new layers of complexity, including the need for robust cybersecurity measures to protect these systems from potential sabotage or malfunction. The economic ripple effects of asteroid mining extend far beyond the extraction of metals. Consider the impact on energy. Asteroids rich in water ice could fuel a hydrogen-based economy in space, powering everything from rockets to habitats. This shift would alleviate the logistical burdens of transporting fuel from Earth, significantly reducing the cost of sustained space operations. However, the establishment of such a supply chain requires significant upfront investment and international cooperation, raising questions about the control and distribution of these newfound resources. Legal and regulatory frameworks present another formidable hurdle. The current laws governing space are ill-equipped to handle the complexities of asteroid mining. As private companies vie for claims in the vast expanses of the cosmos, the potential for disputes over territorial rights and resource ownership looms large. Without clear guidelines, the race to mine asteroids could devolve into a chaotic scramble, with the most powerful entities imposing their will. International dialogue and new treaties will be essential to ensure equitable access and prevent monopolistic control. Financing these celestial endeavors poses its own set of challenges. The initial costs are astronomical, requiring not only visionary investors, but also unprecedented levels of risk tolerance. Yet, the allure of potentially limitless resources continues to attract bold financiers, willing to bet on the next great leap for humanity. Insurance markets, too, must evolve to account for the inherent uncertainties of space operations, from launch failures to orbital collisions. The development of new financial instruments will be crucial to mitigate these risks and enable long-term investment. As we push forward, the specter of orbital debris casts a long shadow over our ambitions. The proliferation of satellites and other space infrastructure increases the likelihood of collisions, threatening both manned and unmanned missions. Effective debris management strategies, such as active removal systems and improved tracking technologies, are vital to maintaining safe corridors in space. The stakes are high, as any significant debris event could set back progress by years, if not decades. Despite these challenges, the timeline for asteroid mining is accelerating. Some experts predict that within the next 2 decades, the first commercial operations could commence, driven by the relentless pace of technological advancement and the growing imperative to secure new resources. This timeline, however, is contingent on overcoming the myriad technical, legal, and economic obstacles that stand in the way. Each breakthrough brings us closer to a reality where space mining is not just possible, but profitable. The dawn of an asteroid-based economy promises to reshape industries on Earth, from manufacturing to technology, in ways we are just beginning to comprehend. The potential abundance of rare materials could lead to the development of new products and technologies that are currently unimaginable. However, this future hinges on the delicate balance of innovation, regulation, and international cooperation. In this new era, the lines between science fiction and reality blur, as the dreams of the past become the ventures of tomorrow. As we contemplate the implications of this interstellar pursuit, we must remain vigilant against complacency. The challenges are immense, but so too are the opportunities. The quest to mine asteroids is not merely a journey into space. It is a reflection of humanity's enduring spirit of exploration and innovation. It is a testament to our capacity to dream beyond the confines of our world and to transform those dreams into tangible achievements. In the end, The story of asteroid mining is not only about the resources we might extract, but also about the new frontiers of knowledge and capability that we will discover along the way. As we stand on the precipice of this new age, the call to action is clear: to boldly venture into the unknown, to harness the wealth of the cosmos, and to redefine what it means to be a civilization among the stars. The first trillion-dollar asteroid is just the beginning. The universe awaits, and with it, the infinite possibilities of our future. As we stand poised at the edge of this new frontier, the intricacies of establishing a sustainable asteroid mining industry become increasingly complex. The technological marvels needed to make this vision a reality are no small feat. Advanced robotics and AI-driven mining equipment must be capable of operating in the extreme conditions of microgravity and the harsh vacuum of space. These machines will need to dig, extract, and process materials with precision and reliability, all while being remotely controlled or fully autonomous. The ongoing development and refinement of these technologies will be crucial to minimizing risk and maximizing yield. Meanwhile, the logistical chain connecting space operations to terrestrial markets demands innovative solutions. Consider the concept of orbital manufacturing. By processing materials in space, we could significantly reduce the need to transport raw materials back to Earth, instead sending down only finished products. This approach not only cuts costs but also spurs the development of space-based industries, from construction to pharmaceuticals, leveraging the unique conditions of zero gravity. One cannot overlook the energy conundrum posed by asteroid mining. While the extraction of resources like water ice can support a hydrogen-based space economy, the initial energy requirements for propulsion and on-site processing are immense. Solar power, augmented by nuclear reactors, offers a promising path to meet these demands, but harnessing such energy efficiently remains a key engineering challenge. The success of this venture will depend on our ability to develop compact, reliable power systems that can function indefinitely in the void of space. The economic implications are equally profound. As asteroid mining becomes viable, the global supply of precious metals could increase dramatically, potentially destabilizing current market prices. This influx of resources might lead to a decrease in the cost of advanced technologies, making products like electronics and solar panels more accessible. Yet, this abundance also risks creating dependencies and economic shifts that could disadvantage certain industries or regions unless carefully managed. Political and legal frameworks must evolve in parallel with technological advancements. The Outer Space Treaty, while a foundational document, provides limited guidance on the exploitation of space resources. New international agreements will need to address the nuances of ownership, environmental protection, and the equitable distribution of space-derived wealth. The geopolitical landscape will undoubtedly shift as nations and corporations vie for influence and control over these celestial resources. The specter of monopolization looms large as well. A few dominant players could potentially control vast swathes of extraterrestrial assets, stifling competition and innovation. Ensuring a diverse and competitive marketplace will require proactive policy measures, and perhaps even the creation of an international regulatory body to oversee space mining activities. Insurance and risk management form another critical piece of the puzzle. Space operations are fraught with uncertainties, from launch failures to unexpected asteroid composition. Insurers must devise new models to assess and price these risks accurately, offering coverage that can withstand the high stakes of space exploration. Additionally, the development of contingency plans and redundancy systems will be essential to mitigate potential setbacks. As we look ahead, the timeline for achieving commercially viable asteroid mining will be shaped by both technological breakthroughs and strategic collaborations. Partnerships between governments, private enterprises, and research institutions will accelerate progress, pooling resources and expertise to navigate the many hurdles ahead. Some experts predict that by the 2040s, we could see a thriving space mining industry, supported by a robust network of orbital infrastructure and interplanetary trade routes. However, the road to this future is not without its perils. The proliferation of orbital debris remains a pressing concern, with the potential to derail progress if not addressed. Innovative debris mitigation strategies, such as laser ablation and tether systems, are being explored, but implementing these solutions on a global scale requires coordinated effort and investment. The promise of asteroid mining extends beyond mere economic gain. It represents a pivotal step in humanity's journey to become a multiplanetary species. As we unlock the resources of the cosmos, we also gain the tools to address some of Earth's most pressing challenges, from resource scarcity to climate change. By developing a sustainable presence in space, we open new avenues for scientific discovery and technological advancement, pushing the boundaries of what is possible. In this brave new world, the line between exploration and exploitation is thin. We must tread carefully, balancing ambition with responsibility to ensure that the benefits of space mining are shared equitably and sustainably. As we chart this uncharted territory, the lessons learned will guide us not only in how we interact with other celestial bodies, but also in how we steward our own planet. The journey to asteroid mining is a testament to human ingenuity and perseverance. It challenges us to rethink our place in the universe and to harness our collective potential for the greater good. As we venture into this new era, we must remain vigilant, constantly adapting and innovating to overcome the obstacles that lie ahead. The universe is vast and its resources plentiful, but it is up to us to unlock their potential responsibly and wisely. Ultimately, the story of asteroid mining is one of transformation, of economies, of industries, and of humanity itself. It is a story that continues to unfold, with each chapter bringing new insights and opportunities. The cosmos beckons, and as we answer its call, we redefine what it means to be explorers, innovators, and custodians of the future. The dawn of this new age is upon us, and with it, the limitless possibilities that await among the stars. As we delve deeper into this cosmic enterprise, the technological marvels required to make asteroid mining a reality are nothing short of revolutionary. Imagine the development of advanced propulsion systems, capable of efficiently transporting mining equipment across the vastness of space. Ion thrusters, leveraging the principles of electric propulsion, promise to transform our ability to navigate the solar system, offering long-term, sustainable travel at a fraction of the fuel cost. These engines, combined with innovative navigation algorithms, could enable precise rendezvous with distant celestial bodies, making asteroid mining missions more feasible than ever before. Simultaneously, the concept of modular spacecraft design is gaining traction. Constructing spacecraft with interchangeable components allows for greater flexibility and cost efficiency. Imagine a scenario where a malfunctioning module can be easily replaced or upgraded, minimizing downtime and extending the lifespan of our spacefaring assets. This adaptability is crucial as we anticipate the unforeseen challenges that come with operating in the harsh environment of space. Yet, beyond the technical hurdles, the economic fabric of space mining is woven with complexities. As we stand on the brink of a new industrial revolution, the need for a robust supply chain becomes apparent. The establishment of orbital refueling stations, utilizing resources extracted from asteroids, could dramatically reduce the cost of space transportation, enabling more frequent and longer missions. These way stations, strategically positioned across the solar system, would form the backbone of an interplanetary logistics network, potentially transforming the economics of space travel. Moreover, the potential for new markets is vast. Consider the burgeoning demand for rare earth elements, which are critical for the production of high-tech devices such as smartphones, electric vehicles, and renewable energy technologies. Asteroids, rich in these minerals, could alleviate supply constraints on Earth, fostering innovation and reducing our reliance on terrestrial mining, which often carries significant environmental costs. As we forge ahead, the financial architecture supporting these ventures must evolve. Investment in space mining presents unique risks, requiring novel financial instruments and funding mechanisms. Venture capital and public-private partnerships will play pivotal roles, but these high-stakes investments demand rigorous risk assessment and management strategies. The potential returns are astronomical, yet they hinge on our ability to navigate the volatile intersection of technology, economics, and policy. The geopolitical dimensions of space mining are equally profound. As nations and corporations race to stake their claims in the cosmos, the potential for conflict and competition grows. The establishment of international norms and treaties will be essential to prevent the escalation of tensions and to ensure that space remains a global commons, accessible to all. Collaborative frameworks, akin to those governing Antarctica or the deep seas, could serve as models for equitable resource sharing and conflict resolution in the space domain. Safety and sustainability are paramount as we push the boundaries of exploration. The development of robust safety protocols and emergency response systems is critical to protect both human and robotic explorers. Furthermore, the issue of orbital debris cannot be overstated. As our skies become increasingly crowded, the risk of collisions grows, threatening not only individual missions but the viability of space exploration itself. Innovative technologies for debris removal, alongside stricter regulatory measures, are urgently needed to preserve the long-term sustainability of space activities. In this rapidly evolving landscape, automation stands as a cornerstone of progress. The integration of artificial intelligence in mining operations promises to enhance efficiency and reduce human intervention. AI-driven analytics can optimize resource extraction, predict equipment failures, and streamline logistics, all while learning and adapting to the unique challenges of space environments. However, the reliance on automation introduces new vulnerabilities, particularly in cybersecurity. Protecting these systems from potential cyber threats is imperative to safeguard the integrity and success of space mining operations. The cadence of launches will also dictate the pace of industry growth. As launch costs decrease, thanks to reusable rockets and increased competition among launch providers, the frequency of missions is poised to rise. This shift could democratize access to space, allowing more players to enter the arena and accelerating innovation. Yet, with this increased activity comes the need for comprehensive traffic management systems to coordinate the myriad of satellites, spacecraft, and missions traversing the orbit. Looking ahead, the timeline for realizing the full potential of asteroid mining is contingent upon overcoming these multifaceted challenges. While the vision of a space-based economy is tantalizingly close, it demands unwavering commitment, collaboration, and ingenuity. As we stand on the cusp of this new frontier, the lessons we learn will not only shape the future of space exploration, but will also redefine our approach to resource management here on Earth. In the grand tapestry of human progress, asteroid mining is but one thread, albeit a transformative one. It embodies our enduring quest to explore the unknown, to push the boundaries of what is possible, and to harness the vast resources of the universe for the betterment of all. As we embark on this journey, let us do so with a spirit of responsibility and stewardship, ensuring that the benefits of our endeavors are shared equitably and sustainably across generations. The cosmos awaits, and with it, the limitless potential of a future forged among the stars.